Hello everyone, today's video is on factorization. So the first subtopic under factorization is we are going to factor out a perfect square polynomial. First is, when can we say that a given polynomial is a perfect square? We can say that it is a perfect square if considering a three-term polynomials or polynomial, and then this is considered the first term, the second term, and the third term. If the first term is a squared and the second term is b, and the third term is b squared, so you get the first term, which is a, you multiply it with the third term, which is b, and you multiply it with a constant 2 here, so we can say that it's a perfect square trinomial. And every perfect square trinomial or polynomial can be expressed as a plus b quantity square. For example, in example 2, we have 16x squared plus 40xy plus 25y squared. Is this a perfect polynomial, or is it a perfect square polynomial? Let us check. So the first term is 16, so which can be expressed as 4 squared copy x squared plus 40xy, plus the third term, which is 25y squared, can be expressed as 5 squared y squared. So we can have now 4x quantity squared plus 40xy, plus this now can be expressed as 5y quantity squared. From the formula, we have a squared plus 2ab plus b squared. This is the formula that we will be using. Now, we know that our a is equal to, so in this case, a is equal to 4x. b is equal to b is equal to 5y. And let's break this middle term first, which is 40. For us to break that one, we know that we have, from the formula, we have 2 here, the 2. So I will bring out 2. So this will become 20xy plus we copy 5y squared. So if you're going to take a look with a and b, if I multiply a and b here, I will get 20xy, which is there. And then I have the constant 2, which is there. So obviously, this polynomial is a perfect square. So we can write that one as what? Equal to a plus b quantity square. So meaning our a is 4x plus our b is 5y, and we can square it. So that is now the answer. Now, let's discuss formula number 2. For formula number 2, we have here a polynomial still, but we have the negative symbol there. So same with number 1, only that it's minus after the first term. So that can be written in the form a minus b quantity square. So let's have this example here. First, our a first term can be expressed as 2 squared x squared minus 12xy plus 9 can be expressed as 3 squared y squared. So we will have now 2x quantity square, copy minus, we copy 12xy, and then this can be expressed as 3y squared. So we will break the middle term because we have the constant 2. We know that from the formula there, we have minus and we have 2 constant there. So we can have 2x quantity square minus 2. So 12 is divided to 6. Okay, xy plus 3y quantity square. So in this case, our a is equal to 2x, b is equal to 3y. If I'm going to multiply them together, I will get 6 xy, which is there, and I have constant 2. So meaning 4x squared minus 12xy plus 9y squared is a perfect square polynomial which can be expressed in the form a minus b quantity square. So our a is 2x minus our b is 3y, and then we can square it. For example number 3, we are going to do the opposite. We are given the factored form and we're going to expand this into a perfect square. So we will still be using the formula, both formula, and then we know that this is plus, so obviously it should be in the form a squared plus 2ab plus b squared. So our a here is equal to x, our b is equal to 1. So from the formula, we will raise or square the first, or the a. So we have x squared. So you multiply a and b, so a is x, b is 1. So we multiply 1 times it's x, times the constant 2 at the middle. So it will become 2x, and then you square the last, which is equal to 1 squared. So obviously it's x squared plus 2x plus 1. And that is the expanded form of this. For number 2, it's the same. Letter B, I mean, it's the same, only that it's minus in there at the middle. So the same thing we are going to do. We have a, we have b. First is we square a, which is x. So we have x squared. You multiply a and b, you will get 2x times the constant 2 from the formula. So we will have 4x, and then plus you square the b, so we will get that. So obviously the expanded form of that is x squared minus 4x plus 4. For example number 4, we are going to complete each of the following expressions by adding a constant term to make it a perfect square. We're going to express the answer in the form x plus a quantity squared, where a is a number. So if we have here x squared plus 4x, we are asked to make it a perfect square. So we are going to find the missing number there. So to do that, what we are going to do is actually get the half of the coefficient of x. So the coefficient of x here is 4. So 4, we will get half of that, and then we will square it. Okay, so after getting the half, you need to square it. So obviously, we will get x squared plus 4x plus 2 squared, which, as you can see, it is now a perfect square because this is our a, this is our b. So when you multiply a and b, you will get 2x times the constant 2 from the formula, you will get 4x. So you can now express that one in x plus 2 quantity square. Number 2, same thing that we're going to do. We are going to find the last term there, but to find that, we will get half of the coefficient of x, which is negative 4. So we have negative 4, half of that, and we're going to square it. So obviously, you will get negative 2 square is positive 2. So you will have now x squared minus 4x plus 2 square, so which is now equal to x squared minus 4x plus 4, or you can now write that one in the form x minus 2 quantity square. Number 3. So we are going to get the third term here. So half the coefficient of x. The coefficient of x is b. So we have b, half of that, and then we square it. So obviously in this case, we have now x squared plus bx plus b over 2 quantity squared. This is your a, this is your b. When you multiply them together, you will get x b over 2. When you multiply 2, you get 2b, 2x I mean, bx I mean. So you have now x plus 2 b over 2 quantity square.